Hello friends, welcome to the session on data structure. In this session, we'll be discussing one more operation on the stack, and this operation is being called as a traversing operation. Friends, already we have seen different data structures. We have seen why it is necessary to study the data structure. Stack is a very useful data structure, and as I earlier said you, that in many applications, people need to make the use of the stack. Say for example, if you study computer science, you will find that there is a subject of compiler designing. In the compiler designing, it consists of many algorithms. Whenever we write any program in a high level language, then this high level language program is being translated into a machine code. And for the translation, they require some algorithms. And these algorithms actually make the use of stack. So many algorithms in computer science are implemented by using only stack. So the operation that is frequently needed to perform on the stack is the push operation, pop operation. Already these two operations we have discussed in earlier session. As far as this session is concerned, we'll be discussing about a traversing operation. Friends, I am recording these sessions for PSS Central Institute of Vocational Education for the course Junior Software Developer. You will find that these are the sessions on the unit data structure. Friends, as we know that a stack is a kind of a list, but it is different from the array list because it is a list where the insertion and deletion has to be performed from one end only. So whenever we want to insert any element into the stack, it has to be done from one end, and whenever we want to perform deletion operation on the stack, it has to perform from the same end because the other end of the stack is closed. And it is like a cylinder, isn't it, where the lower end is closed and the cylinder is open only at the upper end, and whenever you want to add into the cylinder, you can do it from that end, and whenever you want to remove anything from the cylinder, you have to remove from that end only. So stack is a data structure where the first element, whenever you add any first element into the stack, it will go to the bottom, and the element that is being added in the last will remain on the top of the stack. And that is the reason many times you will find that the stack is being called as a last in first out list, or sometimes in short we call as LIFO list, last in and first out. So whatever is the last inserted element, it will be out first because it is on the top of the stack, and therefore it has to be deleted first, then only you can delete the next element. And the element that is being inserted in the end will be taken out the first, and that is the reason we call it as a LIFO list. So as shown in this diagram, one can easily observe that we have a pointer to the stack, and this pointer is being called as the top pointer. And this pointer is very important because it will tell us where the top of the stack is, and it will also tell us that from where we can make an access to the elements of the stack. Traversing, already we have discussed in arrays. In arrays, we have already discussed how we can make an access to each and every element of the array. Similarly, the traversing operation in the stack is also the same thing, that is, we want to visit each and every element of the stack. In many algorithms, it is needed that you should go by visiting to each and every element of the stack. Visiting means you will read the element. Visiting means you may apply certain process to the elements of the stack. But whenever you want to apply any process to the stack, or whenever you want to read the element of the stack, then it is necessary to make a traverse operation to the stack. And traversing can be done only when there are certain elements in the stack. If the stack itself is empty, then we will not perform any traversing operation because there are no elements in the stack. But if the stack consists of certain elements, then of course we can perform the traversing operation. So traversing operation, how can we perform the traversing operation? As I told you, whenever you want to perform any operation on the data structure, then you need to write an appropriate set of steps, and this set of steps is being called as an algorithm. So for every operation you need to write an algorithm. Once you write an algorithm in a proper way, then these algorithms can be converted into programs by using any programming language. Say for example, if you are familiar with the programming language like C, C++, Python, Java, then these algorithms can be converted into programs by using these programming languages. As shown in this diagram, if my stack itself is empty, then the top of the stack will point to the lowest element, and the lowest element is null or nil, and therefore as far as empty stack is concerned, we will not make a traversing operation. So while writing the algorithm for the traversing operation, we will always check whether my stack is empty or not. So these are the steps of algorithm for traversing operation. So the first step is that you have to check whether your stack is empty or not. If it is empty, no need to perform the traversing operation, and in that case we will simply display the message that the stack is empty, and we will stop or we will exit the algorithm. So our first step is check whether stack is empty. And how can we check stack is empty? Just by looking at the pointer top, because top will point to the lowest element and top will point to the null, and therefore we can say that it is empty. And in that case we will display the message that the stack is empty, and then we will exit the algorithm. But if the stack is not empty, means if the stack is consisting of certain elements, then what we will do, we will assign the value of the top to the variable x. The value that is being pointed by the top pointer will be assigned to the variable x, because top is a pointer, it will point to a memory location, and the memory location will hold certain value, and this value will be assigned to the variable x. Means we are reading the value. As I said you that in traversing operation, either we read the value or we apply some process to it, but it depends upon in which application you are making a traversing. So as far as this algorithm is concerned, what we are doing is that we are just reading the value of the element. So whenever we want to see the next value, what we will do is that we will decrease the x by 1. We will decrease the x by 1, and then again we will repeat the step, so that means the value of x is decreased because initially x is being assigned to the top. Value of x is now decreased, so we are coming to the next element, and now we can read the value of the next element, and in this way we goes on until we reach to the end of the stack, or we reach to the bottom of the stack. So this is the way by which you can perform the traversing operation. Suppose I have been given a stack where there are 4 elements and the capacity of the stack is 4, and now top pointer is pointing to the element 40. So what I will do initially, I will assign x is equal to top, so that we can make an access to this 40 value. Then we will decrement the value of x by 1, and we will go down in the list of the stack, and then we will read the next value 30. Then again we will decrement the value of x by 1, and then we will go down and we will read the next value 20. Then again we will decrement the value of x by 1, we will go down and we will read the next value 10. And now already we are at the bottom of the stack, and therefore we will stop reading because all the elements of the stack have been accessed and their values are read, and therefore our traversing operation is being completed. So this is the way you can perform the traversing operation on the stack. So thank you friends for viewing the session. Hopefully you have understood how it is possible to perform traversing operation on a stack. Thank you all.